programme. So we meet monthly in central Birmingham on a weekday evening, so it's the first Wednesday of every month.
Unless it's a World Cup.
Unless it's a World Cup. So why attend? It's a great way to network, great way to grow your skills, share best practices. I think especially in a competitive market like today, give yourself an edge against the other companies that you might be against. Talking recruitment for one moment, if anyone wants to talk about hiring or looking for a new role, if you want to come and find me, I'd be more than happy to speak to you about market intelligence at the moment that we're seeing. So we're going to be kicking off with Darlington. So Darlington will be talking about from raw logs to insights, building behavioural analytics dashboards with Power BI. We'll then have a short break as normal. We'll be resuming with Shivangi Goyal. So Shivangi will be dialing in remotely on Teams, and she'll be speaking on navigating the ethics of data accuracy. So the next two sessions will be in this office once again. So the next session in September, we're going to be joined by Vlad Migata, and he'll be doing Power BI embedded analytics and beyond. And Neil Rowlands will be demonstrating creating a Power BI training program. We'll then be back here in October, where we'll be joined by Victor Rivas. So Victor will be covering from floor plans or diagrams to dynamic dashboards, synoptic panel in Power BI, and Jerome Witashim, who will be doing managing successful data projects, a balanced approach, double checking which should be in person. That part wasn't meant to be on there, so just forget that part.
The presentation title.
Yeah, a little bit extra. Venues and speakers, as ever, if you would be interested in speaking, or if you know somewhere where we could host these events moving forward, please do let us know. Just come and find myself or one of the other people in the organising team. I have printed off the barcodes, so if you could leave us some feedback on the events, we'd be really grateful. As I said, the feedback we can use moving forward, it does really help us, so please do. If you want to do this one, as I said, I've printed them off, they're on some of the tables around here, so we'd really appreciate that. And then I'll hand over to Darlington. Thank you.
So, first of all, I want to thank everyone who is available today. Thank you for coming today, and thank you, Mark. Thank you, Mark, for hosting this meetup where we can collaborate. As I believe we have data analysts here in our midst. We have data experts. We have data professionals. Whether it's your first time in data or you're an expert in data, I believe this session will be of immense value to you. So, I'd say a little bit about myself, right? So, I am Darlington, okay, like you mentioned. I've been in cybersecurity for about 5 years now, right? So, most of the things I do is penetration testing, vulnerability assessment, exploitation, remediation, threat analysis. However, today I'll be talking about Power BI dashboard. And what I'll be talking about Power BI dashboard is part of my own research in cybersecurity. Some of the logs that was done can be ingested into Power BI, right? So part of the telemetry I'll be discussing about will be about cybersecurity and how it can be of analytical intelligence to its users. So most times we believe that raw data or raw event data becomes valuable when it is shaped, modeled, and communicated. But naturally, that's not true. And I just want to ask a question because it's going to be interactive. I want to ask who amongst us have used Power BI, who is if you have used Power BI, can you just wave? Okay, so I believe everyone understands what I'll be talking about. So it's going to be interactive, right? It's a place where we can share ideas, share opinions, and challenge each other's thinking. So if you have a different perspective of what I'm saying, you can put that down on your note, and we can talk about that when the question and answers section is. Okay, so usually, how many of us believe a prediction is not an insight, or do we believe a prediction is an insight? So, when we talk about predictions, is a prediction an insight, or is a prediction not an insight? So, if you believe a prediction is an insight, can you raise your hand up?
Depends on probability attached to it.
All right. So, actually, in terms of predictions, right, a prediction is not an insight, right? Because for a prediction to be an insight, they have to be like analytical, and they have to be like an analytical structuring for a prediction to be an insight. So, in terms of the structuring, right, it has to go through a pipeline. Right, so we understand that it has to go through a pipeline. The pipeline is, there have to be the ingestion of the information, there has to be data transformation, data shaping, analytical modeling. There have to be analytical modeling, and there have to be dashboard when it goes to the dashboard. And that's not where it ends, right? When it gets to the dashboard, it also has to, the data analyst, right, has to be able to look at the dashboard and interpret intelligence, right? So when it gets to when as a data analyst, when you look at the dashboard, interpreting it to form an analytical intelligence also matters. And for that to happen, what this means is that a prediction, right, is not an analytical intelligence. It's not an analytical intelligence, right? And a dashboard is not an insight. What makes a dashboard an insight is the level of analytical intelligence that the data engineer or data analyst looks into the information and can predict. That's what makes it an analytical intelligence. So there's a pipeline. It goes from raw logs, then to the Power Query. The Power Query, this is where the data preparation happens, where there is normalization, there is where you shape the data, when you remove the inconsistent values from the data, and where you interpret it in a form that the analyst would need the Power BI to receive the information, right? So it's very important to understand that in terms of this is what we see on the other side is a prediction, right? It's a single output. And this single output, right, we have timestamps, event types, username, source IP, destination host, attempts, geolocation, risk score, alerts, and so on. So this is an individual event. It is meaningless, doesn't have any output. Looking at this, putting just this in the Power BI would produce nothing, right? So this actually has a very limited context to what we need. And this is in the traditional sense, we understand that Power BI, traditionally, we use that to interpret sales, interpret business intelligence, interpret marketing insights, and other things, right? But in terms of telemetry is more advanced, and this is when consistent and continuous output or raw events come in place. And this consistent raw output, right, it's what you use to build the data. So, what telemetry is usually messy, right? So back in the days, you understand that Power BI has really advanced to the level where traditionally the input that we put in the Power BI is usually structured, right? It's usually structured in the sense that you have to prepare the log, you have to prepare the columns, you have to prepare the rows, you have to prepare everything you need, right? And this preparing that, right, it's a structured, right? That comes out in a structured manner. But in telemetry is quite the opposite, because it is semi-structured, right? It's semi-structured, and it brings out valuable information, right? You can interpret that information, but it's still not, you cannot be able to like put that information in Power BI and it automatically would provide you an insight. And if it does provide you an insight, it might not be as intellectual as you want it to be. So most of the questions that's asked in this stage is, so many analytical and machine learning are designed to answer specific questions. For example, when you look at this single output, that's the JSON output, you start to ask questions. You start to ask questions such as, is this malicious or not? Or is this process malicious? Is as an anomaly occurred, or did this event exceed a threshold? Right? But in real operational environment, the answer to those questions is not usually enough. There are other questions that it leads to. For example, when you look here and you see that this is a CVSS score of 8.8, right? That's a vulnerability score. So you try to ask the question, is this score high or not? Or looking at this score, you wouldn't be able to determine if it's high or not. You need more information to be able to understand if it's high or not. So a prediction without analytical context has very limited value. But that's very limited value. And systems usually generate outputs such as labels, probabilities, confidence score. However, those outputs is usually not enough, right? That's when it gets to the second stage of the analytical modeling, which is the machine learning stage, which it gets to the data collection. When the data is collected, feature engineering, model development, algorithm selection and testing, and then it gets to the performance optimization. So usually, we understand now that telemetry is actually semi-structured compared to the structured way things are done traditionally, where you put your logs there for sales output, customer output, product item, you put down all these logs and columns, right? That's a structured way. But in terms of semi-structured, it's like a continuous information whereby it's continuous, right? So it's continuous, and being that it's continuous, because of the continuous extent of the information, it leads to further questions. Some questions it's going to ask is, okay, being that it's continuous, it can actually have an adverse effect on the output, right? That's the high cardinality. For instance, when you have random numbers like hashes, or you have numbers like digits, right? So there have to be a level of modeling to those numbers for it to be able to interpret, or otherwise the information that comes out from the Power BI, it becomes inconsistent. You'd have some rows or some columns that's not useful to the analyst. So usually when this happens, that's when you go back to understanding. You ask yourself some questions like, how will output be monitored? And this is the analytical gap. You start asking questions like, how would output be monitored? How will recurring behavior be identified? Right? So common examples of raw telemetry is JSON. This is the first example. And another example is the XML, that's extensible markup language. And we have the application logs, we have API responses, and we have event messages, right? So a single JSON event might contain timestamps, might contain the date, it might contain name, it might contain type, it might contain IP address, it might contain vulnerability, it might contain ID, and other information like this. But if you have to ingest this into a Power BI, right? you understand that some of the information here might not be valuable, and you need to take them out. That is when the data shaping comes in place, and that is, if you look at the nested information, we have a nested information here, which is the name, type, and IP address. So some of the information needs to be taken out for it to produce a meaningful insight. Right? Some of the information needs to be taken out. So some fields, we can come across some fields missing. We can come across some null values. We can come across some inconsistent values and some data types and timestamp format errors, right? So this requires that it needs to be the data shaping, right? So we need to understand what the raw telemetry is all about before we move to the next slide. So raw telemetry must actually be engineered for analytics. It's not about, you need to engineer the raw telemetry for analytics. Okay, so the next question I ask is, looking at this raw telemetry, could anyone confidently build a dashboard from it? Like those who have used Power BI, can you build a dashboard from just this telemetry? Okay, so I believe no, right? Because it's just an output, right? So you cannot build a telemetry from something like this, right? So next slide. So this is a simple design about how the raw logs move, right? So usually the first stage is the raw logs. That's where you ingest the output. The first stage is the raw logs, and at this point in time is where you need to put the information that you have. So the raw telemetry could be in the form of a collection of JSON files. It could be in the form of application database. It could be in the form of API, cloud storage location, and log management platform. So already I explained this in the previous slide. This is when we understand what raw logs, what telemetry is all about. Now we're going to move further to the Power Query and Transform. So the Power Query it's the data connection and transformation engine used across Power BI, and we all know that Microsoft is leading in the product. So, and this is where transformation happens. And when the transformation is done in this part, you can actually use that repeatedly on other raw logs. So you can use that repeatedly, you can use that continuously, right? Yeah. So then we move to the next one, which is the analytical modeling. And this analytical modeling, this is where you model the output, where there is efficiency in the output, and then the data analysis expression. This is more of the calculation. This is where the calculation is done. And then the dashboard. So then move to the dashboard where the visualization is done. As an analyst, you put in the dashboard what you want to see, right? And then insight. So insight is a collection of raw logs, Power Query, analytical model, DAX, dashboard. That's what insight is. So insight is the collection of that. So insight is created across the pipeline, not just at the visualization stage. So it's created across the pipeline. So from the raw logs, that is when you ingest the data type you want, the data output, and then you transform it. That is where the data shaping and the data modeling, data transformation comes in place, where you put it, the nested value, the inconsistent value, you transform it to the way the Power BI will be able to understand, and then you model it. This is now where you do the modeling, and then finally this is the calculation, the data analysis expression, and that's when you do the calculations. That's the behavioral interpretation calculations, and then it moves to the dashboard. And when it moves to the dashboard, as an analyst, you put you design the dashboard based on how you want it to be meaningful to you, and a collection of everything is the insight. That's where you do the investigation. So now we'll look at one of the next stage, which is the data shaping and transformation. So that is the Power Query stage. That's now we're moving to the data shaping and transformation stage. Yeah. So as you can see, now we're going to talk about the data shaping and transformation. This is an example output of how a cybersecurity analysis is. And like I explained initially, this is before and after. This is before the output, and this is after the output. So, and what we see here is the process of the transformation. As you can see now, we still have the timestamps, we still have the event type, we have the username, source IP, destination, host, attempts, risk score, alert, action taking, action log. So now, account log. So now, where we need to, in the sense of this, flattening the JSON. So we need to flatten the JSON. How do we flatten the JSON? So if you look at this diagram, you see that the JSON is flattened, right? Because this output produces this output. So instead of this the JSON format, it has flattened it into timestamps, event type, username, and it has got out all the inconsistent or the commas. The commas are no more longer there and everything. So this is how it shapes the data. Then finally it goes to data cleansing. So in terms of the data cleansing, this is when you remove any values or any values that would be irrelevant to the data, right? So in this stage, this is where you remove any invalid records, you handle blank values, you correct the data types, and you standardize the timestamp, and you remove the duplicates, right? So depending on the design, this can be separated into dimension table and connected to the central event table using the Power BI. So the next one would be the normalization. So normalization is more of normalizing the output, and in terms of the normalization, normalizing means organized repeated information into related structure instead of storing the same descriptive values repeated in every row. So instead of storing the same descriptive value, for example, if this output, we are dealing with about 50 of this output, right? So instead of, if you have a lot of, for example, malware types, I'll use like malware types. We have Trojan, we have rootkits, we have phishing, and we have malware types. So instead of putting that in, like putting that and bulking the information, we can actually just put it in a malware family, right? So that's normalization. So normalization is just like trying to put it in a malware family, and then in that malware family, it has all the malware types in it, right? So this makes it easier for the data analyst to be able to shape the data and transform it. Then we move to the next one, which is the enrichment. So enrichment is all about adding meaning that did not exist explicitly in the raw data. Right? You decide you want to add some bit of meaning to it. Decide you want to add a low, for example, like you want to, like for the risk score is 92, you want to rate, you want to say, okay, from 0 to 20 is low, right? And then from 20 to 40 is medium, and then from 40 to 100 is high, depending on how you want to do it. So that's when you enrich it. You can say, you can have aspect like low, medium, high, critical, you know, and then finally you move to the feature engineering. So feature engineering is more of like the modeling aspect, you know, so identifying whether an event occurred outside the normal operating hours, you know. So so the key message here is Power Query does not merely clean data. It defines the analytical meaning and structure that everything else depends upon. So once the data has been transformed, we will still need to organize it correctly. So once this data has been transformed, once you're done transforming the data and analyzing the data, we will still need to analyze it properly. That's once the data has been transformed, we still need to organize it correctly. Clean the data is not automatically a good analytical data. So here is a diagram. Here is a diagram of device types and everything. I'm sure it's because of the enlarged screen. So here is a diagram of a star schema, right? So after transformation, the next challenge is analytical modeling, right? And next challenge is analytical modeling, and a common approach is the Power BI star schema, right? So this fact table stores measurable events. So here it stores the measurable events. It stores measurable events here, and it stores the analytical events here. That is device time, category, event type, behavior, model version. So the measurable event stores it in the middle, and the analytical event stores it there. So all these, when outputs are put in there, everything comes to the middle. That's the star schema. So this separation is very important because it reduces repetition and creates analytical relationships. On top of this relational structure, Power BI provides a semantic layer which defines how users interpret and analyze the data. Okay. So this is where you can say, okay, for the time you want to do time zones, for the device you want to do device types, for the model version you want to do okay, iOS model, for the behavior, event type and category. This is where you define for the time you can say, for the data table you can say for day, week, monthly, quarterly, yearly. You know, this is where you can be able to have a reasonable relationship with the data. So the semantic layer transforms structured event data into reusable analytical language. And once the semantic foundation is in place, we can move beyond individual records and begin measuring behavior across time. So this is the next slide, which we are going to be talking about the interpretation of the data, that is data analysis expression. So at this stage, Power BI begins to move beyond conventional reporting into behavioral analytics. So at this stage, now we are getting more impact, more meaningful behavioral analytics with this stage. So behavioral analytics, so at this stage, this is where we can start to measure, like, for example, when we say total sales, profit margin, year-to-date performance or percentage growth. So we can now be able to calculate, okay, the number of events that happen, the percentage classified as anomalous, right? The average confidence score, the number of affected devices. So this is where we can start to like get more behavioral information about the output. So behavior does not normally appear in a single row. emerges through aggregation, comparison, and time series analysis, right? So once this behavior measure exists, the final challenge is usually how to communicate effectively through the dashboard. That's the final challenge. How do we communicate it effectively through the dashboard? So, but before I say anything, I want to ask a question. The question I want to ask is, which tells you more about a system, one event or the pattern of thousands of events over time? So in terms of like, which one tells you more of a system, right? Is it one event or the pattern of thousands of events over time? Pattern, thank you very much. So the patterns tells you more than one event. So usually what this means is that the more patterns or the more evidences that you get, the better information the better the information. And this has what leads us back to the dashboard design and investigation. So usually what happens here is that it does not only summarize what happened, it helps us examine patterns evolve. So when we get to this stage, the behavioral analytics with data analysis expressions, help us to understand the patterns that evolve over time. So this is the stage where we understand the patterns that evolve over time. So first we talk about the first one we look at is the raw events, and from the raw events it moves to the Power Query data shaping and transformation, and from the Power Query data and transformation it moves to the modeling. From the modeling it moves to the analytics, behavioral analytics, and then it moves finally to the dashboard. So when it gets to the dashboard, this is also a very important part of the whole pipeline, because at this part you as an analyst will decide how you want the dashboard to look like. You want it to be informative, you want it to be descriptive, you're going to decide how you want it to look like at this point. So the dashboard are designed differently from many traditional executive reporting dashboard. So the objective here should not just be visualization, it should be investigation. So at this point in time, you want to be able to create your dashboard that provides a valuable investigation into your own domain. So you want to create a dashboard that identifies unusual activity, changes over time, concentration, if you're able to see deviations, possible relationship between events. So when it gets to this point, this is when you can actually prove that you actually understand how to align your output to provide a very proper investigation into what you're doing. So you will have to be able to do it in a way whereby you can be able to understand. For example, in my own telemetry, you can be able to know when an increase begins. When an increase begins, you can be able to know which category contributed to it, which device or entities were affected, how confidence score changed, and which underlying events may require further investigation. So different visualizations serve different analytic purposes. My own type of visualization might be different from your own type of visualization. So your own type of visualization, you might need a different meaning to your own type of visualization. So your own meaning to your own type of visualization might be different from my own meaning to my own type of visualization. So we can be working on the same raw telemetry, but trying to get different meaning out of it. Yeah, and this is where you understand you can put your line chart, heat map, distribution charts, bar charts, scatter plot, detailed tables spot, and other of the visual matters. So this creates a natural investigation workflow. What changed? What did it change? Where is it happening? What contributed to it? Which record provides evidence? Right? So good dashboard reduces complexity without hiding important details. So when you go to a dashboard, you need to be able to see a dashboard and know where you're going, know what you want from it. See, okay, this is what I want. You don't need to be too complex. You don't need to go to dashboard and the most important details is the list. So it has to be something that you can easily interact with. something that you don't spend so much time on the dashboard trying to figure out what to do, or something that you go on the dashboard and at the end of it, you're not able to get any meaningful output out of it. So a behavioral dashboard should support a sequence of questions, not merely display a collection of charts. It should support questions. Although the examples in this session originated from my cybersecurity telemetry, but the underlying approach applies to many other analytical domains. So it does not matter if it's a recruiting organization, or it's a cybersecurity organization, or it's an insurance organization, or it's a retail organization. It applies to everyone. It applies to everyone, right? So it's beyond security analytics, it's beyond security analytics. So in terms of fraud detection, it could be suspicious pattern. You could be looking out for failed transaction. You could be looking out for suspicious transaction. You could be looking out for So in terms of fraud detection, what do you think we can look out for in terms of fraud detection? Like
exceptionally large transaction amounts.
Yes, thank you. Yeah, exactly. So we can be looking for exceptionally large amount transaction it can come in on a dashboard on your mobile phone, right? Banks use dashboards. That's when you go on your app. That's a dashboard on the app. So in terms of IoT, you can be looking for sensors. It can be looking for processes. It can be looking for systems. It can be looking for sensors and radars and things like that. So whatever it is, web analytics can be looking for clicks. It can be looking for APIs, and application cloud services. It can be looking for user accounts and application accounts and others and the rest like that. So whatever it is, whether it is security analytics, whether it is fraud detection, observability, web analytics, Internet of Things. So whatever it is, it can be applied to all domains, on all areas. So the example so this is very important, because at the end of the day, what we need to understand, what we need to take home from here is that machine learning alone does not automatically create insight. Raw logs does not automatically create insights. A prediction is not an insight. A dashboard alone does not provide intelligence. So what provides intelligence is how it is structured, how it is modeled, how it is analyzed, how it is communicated, how it is interpreted, and how it is communicated effectively. Right? And that's the reason why we need to understand the pipeline, the journey through till we get to the insight stage. What is the journey? The journey it goes from you generating the machine-generated event data, and then moves through to the Power Query, which gives that analytical structure, and then it goes to the semantic model, which provides the context, right? And then goes down to the dashboard design, where we can understand the patterns and begin our investigation. And ultimately, it's not only about building dashboard, but it's about providing analytical intelligence through a dashboard. Thank you so much.
Questions? Yes. Okay. Thank you very much for this presentation. Can you shed a little bit more light on the Power Query part? I'd really like to know how you moved that data from the JSON format into the structured version that you have.
Okay. So for the Power Query, in terms of the data, right? When you go on your Power BI and you want to ingest the data in there, so it's going to ask the data type you need. So it's going to ask, what data format are you inputting into the Power BI?
Yeah.
Right? So you're going to say, okay, you have JSON format, right? Is it JSON format? So you put, in terms of that JSON format, you put the JSON format in there.
Yeah.
But before putting the JSON format, right, you can do your own data shaping and modeling of JSON format. You remove some nested information you don't want in it, right? You go on your JSON, you go on your coding, right?
Yeah.
And then you remove some of the nested information, some of the output that you don't want to be on that JSON, and then you impute that information on the Power Query,
Okay.
right? And then from there, from the Power BI, you put it there and you can be able to get the output that you want. But then if you're not still satisfied with the output that you want, you can as well remodel it. You can as well remodel it until you get that output that you need. So putting the JSON there is not enough. Understanding the JSON is what really matters. Understanding what you are putting there, understanding the if it's an high cardinality, if there's some information that is inconsistent in the JSON, you need to remove those information, right? You need to remove those information and be able to like make it to be normalize it. You need to be able to normalize it. You need to be able to put it in a format that would produce meaning to you, and then you put it there. So hopefully I was able to answer that question.
Yes.
Thank you.
Thank you very much.
So any more questions, please? You have that.
So I have a question that's related to the previous question, but it's a step before that. So I wanted to understand how you get the JSON files and how, like, where do you store it in order to connect it to in order to connect it to Power BI. So when you load it, does it go directly from your cybersecurity system via API to Power BI, or do you just you have to manually download it and store it in SharePoint and into Power BI? So what's the best practice?
Yeah, I mean you actually answered the question. So you can either do it manually or you can try to automate it, right? You can automate it. So if you want to manually do it, right, you can manually in terms of depends on the JSON you're looking for. But if you want to check a JSON now, I can show you a JSON how it looks like. It's just you have to go to your event, you have to go to your computer event viewer, and from there you can see the logs. So there are logs here in your computer, right? So from there, on the logs, you can see, okay, maybe an account was signed in. An account was signed in. You see how many accounts signed in this computer. All the computers here in the morning when you come in, you see all the accounts signed in. On there, you can see the formats. You can see a JSON format. It's going to be there, JSON format. So you click on the JSON format, and then it prints out in a JSON format, as well as it also shows you a format that is readable for viewers who want to. So me personally, I find meaning in the JSON format more than the format that is printed out. You get, if I see a format that is printed out and I see a JSON format, I'd go to the JSON format first to read it, because that's where I find my meaning from. So you can automate it. There are systems, there are tools you can use to automate it. But I think cybersecurity companies already do that with systems where they can use to analyze alerts. You can be able to use that to analyze alerts. So cybersecurity companies already do that. They put that as a coding. They put that in the code, like where they can able to exfiltrate those information, right? So in terms of that, when you exfiltrate those information, you need permission to do that. You need permission to do that. So you need permission to exfiltrate those information. And when you get the permission, but you can be able to exfiltrate those information and put all that in a JSON format, and then ingest it in the system. Okay.
Yeah. Now, following up on her question, traditionally, let's assume you have a log for cybersecurity, surveillance. What kind of database do you store them in? Let's say for historical data, 5 years back, 10 years back.
So you're asking if I have a log for cybersecurity, what kind of database?
Yes. Do you store them in? Yes.
Is it for cybersecurity?
Yeah.
Okay. So it depends on the data actually, right? It depends on the data you are storing. If it's a web server data, if it's a normal application log data, or if it's a web activity data. So each data has different components. So if you want to store it, right? For example, if it's an application log data, you want to store it. Application, most of the things you see in application, you can see confidential information, you can see logs, you can see all that. But those information is actually stored discreetly with the company.
Okay.
Right? So you still need permission to be able to acquire those information. Right? So those information, when you get the permission, they have their web server there, where you can be, or application server, where you can be able to get those information and be able to acquire them. Right?
Okay. Thank you.
I've got a question. I have to add some context. Have I got like 2 minutes because it's a long question? So we actually had an incident this week in a company, and it was a cyber, and someone apparently clicked the link. They said they didn't, but apparently they did. Right? And what happened was, they had like logging attempts from to his account from South Korea, Russia, and somewhere else, America, I think, right? And there was no analytical intelligence on it. Within 3 seconds, Microsoft blocked all of that. He was blocked out completely. And it was within 3 seconds of the first attempt. Well, the 3 attempts that they kind of tried. So I think my question is, and kind of really contradicting your statement where you kind of need to take that data and go into like this loop of analytical intelligence, whereas actually that was all rules-based, right? Very hard-coded. Like if this person usually is in the UK and there is an attempt from outside the UK, within 3 seconds, that was blocked. So the question really is, do you really need to kind of, take this log data and look at it, whereas the other approach is, actually you need hard-coded rules that actually take action without human intervention whatsoever. Because, no human could ever block that in 3 seconds, right?
Yeah.
Yeah. So I'd say in that situation, they blocked that in 3 seconds, and that was absolutely fast. And I think that is making it going to be easier. But we don't want to do things the hard way. So if Microsoft, right, has already created the things in an easy way for everyone to do, right, we'll go with the easy way of doing things. So normally, in terms of these, right, so I'd say this provides much more insights afterwards, after the data has been blocked. So we can still go back and say, okay, let's analyze the information, but still the output, if it's just 3 computers that it happened to, right, we can still be able to get some information out of that and still be able to put that in the Power BI and still just have that on record and see, okay, it can help provide business intelligence in sense of that.
No, I think it makes sense. I think it's, as a cybersecurity, your number 1 role is to kind of keep safe. And I think with the age of AI, I think no human will ever be as reactive as rules, hard-coded sort of code that will actually, if that, then block.
Yeah, exactly.
I think-
So just in terms of, I want to pick up 2 things in terms of Microsoft security, Microsoft doing mass outs a couple of 100 billion fraudulent requests every day. Not unreal, a couple of 100 billion to a lot more activity. They have very advanced AI, they don't really advertise it. What's going on in the background, the machine learning stuff to about the attempt. In terms of log analytics, in terms of cybersecurity, it's generally scripting after you event, after you've been in the network. So you get the logs where they've been, what they've been doing, and see where they're going, in what sort of order, if they happen on the way out, what things sort of logs and stuff on the way out. So it's very descriptive in terms of the analytics. It's not like descriptive or whatever, but Microsoft don't really talk about how many times a day people try to get access to storage accounts. We've got hacked by Russians on my WordPress account. Quite a bit of that.
Thank you. So any more questions, please?
No, just a follow-up to what his question he asked. Two things are involved in his question. The first one is the actual cyber attack stoppage, which is what Microsoft resolved. And your presentation is more about reporting everything that has happened afterwards. So this is just showing insight of what has happened. Yeah.
It depends on what log telemetry you get in as well. From, if you want to play around the data, the New York taxi company has an API which you ping, you get JSON data in, and play around with predictive analytics and Power BI. So, all sorts of things.
Thank you very much for your question.
Are we good there?
Thank you.
Right.
Thank you.
Any more? Right. Thank you, Darlington. Thank you. Right, everyone, drinks in the fridge, help yourself. Pizza in the back. Matt and I already had to go. It's good.